everyone and welcome to this video. My name is Tina, I'm a H1 chemistry student, and today I'm going to be taking you through the solutions to question 4 from this Leaving Cert higher level paper. So question 4 is always going to be the short questions segment of the paper, and this year it asks us to answer 8 out of the following questions, okay? And it's 50 marks in total. I'm going to go through all the questions just for the sake of the video. So let's get started. Okay, so in this question we're asked to draw a label diagram of Thomson's plum pudding model of the atom. So this is a question that often comes up in the short question section, so it's good to know this and to know exactly how you're going to get your marks. So what you're going to want to draw is a positively charged sphere with negatively charged particles embedded at random within. Okay, so it should look something like this. Okay, now this could be anything. So what we're going to want to do is label it accurately, okay? So I'm going to get my pink pen and I'm going to draw positively charged sphere, and then I'm going to label negatively charged particles. Okay, so there's 6 marks going for this question. There's 3 marks going for the positively charged sphere, and there is another 3 marks going for the negatively charged particles which are embedded within the sphere. Okay, so this question is based on electron configuration, and it tells us that the diagram represents the 10 electrons in the 4s and 3d sublevels of a neutral atom of a certain element in its ground state, and it asks us what is this element. So the first thing I'm going to do is draw out this kind of diagram that's going to help me, right? So I'm going to say n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, okay? So they are the first 4 electron shells, okay, of an atom, right? Okay, so the first shell only has one sublevel, okay, and that is 1s. The second shell has 2 sublevels, 2s, 2p. The third shell has 3 sublevels, which are going to be 3s, 3p, 3d, okay? And then the fourth shell has 4 sublevels, and that is going to be 4s, 4p, 4d, and 4f, okay? So in an s sublevel, an s sublevel can hold 2 electrons. It has 1 orbital, so it can hold 2 electrons. So I'm just going to make a note of that here. So s, p, d, they're the only ones we're going to need, right? So s can hold 2 electrons. P has 3 orbitals, and each orbital can hold 2 electrons, so that can hold 6 electrons. And a d sublevel can hold 10 electrons, so it has 5 orbitals, which each can hold 2 electrons, so it can hold 10 electrons. Okay, so now I'm just going to go through the diagonal rule, okay? So the diagonal rule is like this. Okay, so that means that the order in which the electrons fill these sublevels follows the diagonal rule. So the first electrons go into 1s, the second one's going to 2s, the third one's going to 2p, then 3s, then 3p, then 4s, okay? So that's basically just showing you that electrons fill the 4s sublevel before the 3d sublevel, okay? So that's here why 4s comes before 3d, right? So now let's go through this particular element. Okay, so we know that the 1s sublevel is full. So 1s, okay, 2s must be full, 2p must be full, 3s must be full, 3p must be full, okay, 4s must be full, as we can see, 2 of them in there, so it's full, and then 3d. Okay, now 3d isn't full. We can see here it has 1, 2, 3, 4, 5, 6, 7, 8 electrons in it, okay? So I'm just going to write that, so 8 electrons. The rest of them are full, okay, with electrons, as full as they can be. So an s sublevel can hold 2 electrons. There's 2 here, okay, 2 here. P can hold 6, s can hold 2, p can hold 6, s can hold 2, okay? And then a d sublevel can hold 10, but it's only holding 8. So what we're going to do is we're going to add up all these electrons to see how many electrons are in this element, okay? So that is going to be its atomic number, right? So 2 plus 2 plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 8 is 28, okay? So that is 28 electrons. So if you go to your log tables, okay, and go to the periodic table, find the element which has an atomic number of 28, and that is nickel, okay? So the answer to this question is nickel. So you're going to get 6 marks for saying either nickel or abbreviating it to Ni. Okay, so question C is based on radioactivity. It asks us what isotope is produced when the nucleus of an 24195 Am atom releases an alpha particle. Okay, so what I always do for these questions is I write out the atom that they're given us first, okay? So 24195 Am, okay. So it's releasing an alpha particle, and you'll remember that an alpha particle can be written as 4, 2, helium, okay? So it has 2 protons and 2 neutrons, right? So this is here's its atomic number, and this here is its mass number, or its relative molecular mass, okay? So that's what this atom releases, right? So then what are we left with? So the mass number, 241, reduces by 4. So the new mass number of the new isotope, okay, is going to be 241 minus 4, which is 237, okay? And the new atomic number is going to be 95 minus 2, which is 93. Right, now, what isotope is this? Now we can go to our periodic table, right? And it's not actually on the periodic table page that you're used to, okay, which is page 79, right? You're going to have to go to page 82, which is basically an extension of the periodic table. And what you're going to want to do is find the element which has an atomic number of 93, okay? And that is Np, okay? So you can see that it has an atomic number of 93 and has a mass number of 237, which is perfect. So that is what the isotope that is produced, and that is our answer for this question. Okay, so for this, you're going to get 6 marks. Okay, so question D is quite a random question, doesn't really belong to any chapter specifically. It asks us to write the chemical formula for magnesium sulfite and also the chemical formula for copper 2 oxide, right? So the first one, magnesium sulfite. So you're obviously going to have your magnesium, which is Mg, and then sulfite is SO3. If it was sulfate, it would be SO4, okay? These chemical formulas you probably should just kind of know from doing experiments over the 2 years of your course. They're in a good few experiments. You're just kind of expected to know them. But these questions I find can be quite tricky because it's not something that you're kind of told to learn off. It's just expected that you'd pick them up over the years, okay? And then the next one is copper 2 oxide. So you have your copper, Cu, and then O representing the oxide, okay? So you're going to get 3 marks for both of these, which leaves you with a total of 6 marks. So this is an easy question to pick up marks on if you do happen to know and remember the chemical formulae for the 2 compounds. But if you're not sure, I would prioritize other questions and maybe give this one a skip. And if you need to at the end and you're trying to pick up another question that you could find marks in, just give it a go. Magnesium sulfite, you might get the Mg. You could guess sulfite if you weren't sure. And just give it your best shot if you need to. Right, so question E is based on chemical bonding, right? Covalent bonding, to be specific. And it asks us to give 2 possible shapes of a covalent molecule with the general formula QX3. Right, so Q is going to be our central atom here, okay? So I'm just going to draw them out. So Q, and then you have 3 X's. Okay, so the first one, it can be triangular planar, okay? Like so. So that's our first shape, triangular planar. I'm going to write that here. And the second shape, because it asks us to give 2 possible shapes, okay, is going to be pyramidal. And that is when, so you have your central atom, all right, that has 5 electrons in its outermost shell, right? You still have 3 X's, right? So they'll form 3 bond pairs. 1, 2, 3. Oh, my apologies. I drew 6 electrons around there. And then you form 1 bond pair, okay? So that is pyramidal. So you're going to get 3 marks for each of these, giving you a total of 6 marks for this question. Okay, So this question is based on the gas chapter, and it is a calculations question. You're trying to calculate the pressure. Okay, so we're told that each of the small metal canisters shown in the photograph, and the photograph is in the exam paper, contains 0.36 moles of carbon dioxide. The contents of one canister were released into a flat bicycle tube, and the gas inflated the tube to a volume of 1 multiplied by 10 to the power of minus 3 meters cubed at a temperature of 293 Kelvin. And we're asked to calculate the pressure of the gas inside the tube, correct to two significant figures. Okay, so let's write down what we have. We have the number of moles, okay? So N stands for the number of moles, 0.36. The volume is 1 multiplied by 10 to the minus 3 meters cubed. And the temperature is equal to 293 Kelvin, okay? And the pressure, we don't know. We're trying to work that out. Okay, so what we're going to use for this is a formula, which is PV, okay, is equal to N or T. And that will help you find the pressure, volume, number of moles, or temperature in a question like this, okay? So it is PV is equal to N or T. Now, what are we missing here? P is what we're looking for, pressure. V we have in the volume, and it's in the right units, meters cubed. Number of moles we have, or we're missing. And T, we have the temperature, and it's in Kelvin, which is exactly what we need. Now, or is the universal gas constant, right? And it is 8.3. Now, you don't need to worry about this because it will always be at the very front of your exam paper, okay? So now let's fill this out. Okay, so P multiplied by 1 times 10 to the power of minus 3 is equal to 0.36 multiplied by 8.3 multiplied by 293. Okay, so let's work out the right-hand side first. So we have 0.36 multiplied by 8.3 multiplied by 293. And that is 875.484. Okay, so P times 1 multiplied by 10 to the minus 3 is equal to 875.484. So P is going to be 875.484 divided by 1 multiplied by 10 to the minus 3, okay? Okay, so that is 875,484. So P is equal to 875,484. And that is in pascals, right? But we're asked to give our answer correct to two significant figures, okay? So that means basically two numbers and the rest are zeros. So pressure is equal to 880,000 or 880,000 pascals, okay? But you could alternatively write this as 8.8 multiplied by 10 to the power of 5 pascals, okay? So you're going to get 3 marks for your final answer, whichever one of these you use, okay? And you're also going to get 3 marks for writing basically any step of the method. For writing down this formula, you would have got your 3 marks. Alternatively, just filling it like this, okay, you would have got your 3 marks as well, okay? Just to show that you started with the method, even if you didn't get the final answer, okay? So now let's move on to the next question. So question G is a fairly straightforward question in the rates of reaction chapter. It asks us, how can a catalyst lower the activation energy of a reactant? Okay, and the answer is that it provides an alternative pathway for the reaction to occur, right? And you're going to get 6 marks for this. Now, what does that exactly mean? Okay, so if there was no catalyst in a reaction, the reactants would basically have to work harder, provide more energy themselves, okay? But with the catalyst, there's an alternative pathway or kind of route for the reaction to go, okay, which requires less activation energy. Okay, question H brings us back to chemical bonding chapter, okay, and it asks us, under what circumstances do ionic compounds conduct electricity. Okay, now this is kind of something that you do learn off in the chemical bonding chapter. I would recommend you learn off because it does come up a bit in the short questions, and it's quite easy to understand and easy to learn off, right? And the circumstances are in aqueous solution, or you could say dissolved in water, and in a molten state. Okay, and you're going to get 3 marks for each of these, giving you 6 marks in total. Question I asks us to identify the compound that is the main component of the limescale deposit in a kettle used in a hard water area. So we know from the water chapter that hard water contains a lot of calcium carbonate, okay, and that's why it's hard water, okay? So calcium carbonate is going to give you your 6 marks. You could also write the chemical formula, which is CaCO3. They said in the marking scheme that they would accept magnesium carbonate, okay, MgCO3. Usually when they say accept, you will get your 6 marks, but it's just not the best answer to go with. So if you're looking at a marking scheme and something says accept whatever answer, I wouldn't be so sure to go with that for my own leaving cert, okay? Go with the answer that's given. And the accept answer is just, if you put that down that year, you kind of got lucky that you got the marks. Okay, so question J kind of revolves around ring compounds in the organic chemistry chapter. It asks us to copy into your answer book the structure of vanillin, which is basically this structure right here. I'm not going to copy it in just because it's right here for me. But make sure that you do in the exam, because you're giving up your answer book, you're not giving up the paper at all, okay? So question J part 1 asks us to circle the aldehyde group, okay? So the aldehyde group is going to be the C, double bond O, single bond H, okay? That group here. So this is the aldehyde group. That's just something you're going to have to remember. You should know your carbonyl groups, your alcohol groups, the aldehyde groups, and all of these for the short questions and also for the organic chemistry questions, okay? Okay, so now let's move on to the next part of this question, J part 2, which asks us to write the molecular formula for vanillin. Okay, so this is a simple enough question in that we see what we have. We have carbons, we have hydrogens, and we have oxygens. Now let's just count how many of each we have, right? So for carbons, how many do we have? We have 1 here, we have 6 here. We have 1, 2, 3, 4, 5, 6. 7, okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, okay, sorry, my apologies, so we have 8 carbons, right? How many hydrogens do we have? We have, I'm going to use a purple pen, 1, 2, 3, 4. Now, we know that there's 3 in this benzene ring, 3 hydrogens, 6 carbons. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 hydrogen atoms. And how many oxygens do we have? I'm going to use yellow. We have 1, 2, 3. 3 oxygens. Okay, so that is the molecular formula for vanillin. So you're going to get 3 marks for identifying the aldehyde group and another 3 marks for writing the molecular formula. So now we're on to the final question, question K, and this gives you the option. If you choose to answer question K, you have another option whether to answer question A or question B. So question A is based on environmental chemistry, which I know not too many students do, okay? And the question B is based on organic chemistry. So question A asks us to write a balanced equation for the photodissociation of ozone, right? So the formula, or the balanced equation even for this, okay, is going to be ozone, which we represent O3, okay? And then dissociates into an oxygen molecule, and then a free radical of oxygen. Okay, so you must make sure you have the dot afterwards. So this free radical, it may recombine with the molecular oxygen, right, to regenerate ozone. Okay, so it could combine with this O2 to regenerate ozone, okay, completing the ozone cycle. You don't need to say that. That's just an extra piece of information. Okay, so all you need is this balanced equation and you're going to get your 6 marks. Okay, so that's for question A. Now, question B asks us to draw the structure of the monomer used to make polyphenylethene. Okay? So, this is polyphenylethene, right? Is ethene where one of the hydrogens has been replaced by a phenyl group or a phenyl group. Okay? So, first of all, let's draw ethene. So, ethene has 2 carbons, a double bond between them, okay? And then you have 2 hydrogens here, and you have 2 hydrogens here. Okay, but one of the hydrogens has been replaced by a phenyl group, yeah? So let's take this hydrogen out of the question, right? And add on a phenyl group, which looks like this, okay? So it's a hexagon. Okay, and then you have a double bond here, a double bond here, and a double bond here. Okay, so that's all you need. Just make sure that it's connected up there. Okay, so this is all you need to draw your polyphenylethene, okay? And you get 6 marks for that, okay? So this phenyl group, just to clarify, there's 6 carbons, 1, 2, 3, 4, 5, 6, okay? And they're all attached to a hydrogen, right? But then these are double bonds where the lines are, and the rest of the carbons are just attached by a single bond. Okay guys, so that's all for this video. I hope that you found it helpful. I just like to remind you that I went through all of the questions, and you do not have to do all the questions in the exam. As it says for this year, you only had to answer 8 of the following questions, and we went through the whole lot of them. So my advice would be to pick the 8 that you're the most comfortable with, do them first, and then when you have time at the end, go back and give the other ones your best shot if you're looking to pick up more marks or if you're unsure of some of the 8 that you've already answered. So thanks very much for listening, and I'll see you all in the next video.